Hey everyone, welcome to a new video. My name's Jason. Thanks for checking out the channel. In this channel, I'd love to talk about solar power and batteries, and what a better way to combine both of those than in an all-in-one power station. Now, power stations are designed to be used as backup power sources if the power goes out, and an all-in-one solution is perfect for someone that's not quite comfortable with DIY setups. So they do cost a little bit more, but you get everything and it's easy to use because it's all put together. Now this is the Bluetti AC300. This is one of the biggest power stations I've tested on the channel, and it's one of the best solutions that's currently available. Now this offers lithium iron phosphate chemistry, so you can get 3,500 life cycles, meaning you can discharge it and charge it up. That's one life cycle. You can do that 3,500 times and only use the top 20% of the life of the battery, so you still have 80% of the capacity remaining to use after that. Now this power station offers 4 expandable batteries, so if you have one of them, you can get 3,000 watt hours, and if you have all 4 of them, you can get 12,000 watt hours or 12 kilowatt hours of capacity, which is absolutely crazy. Now in my house, I've been using this connected up to a transfer switch dedicated with 6 circuits, and I've run multiple fridges off this. I run my office off this. Basically everything that I've wanted to test, this one runs just fine. Now this also offers a ton of charging input, including 2,400 watts of solar input on 2 dedicated NPPT solar charge controllers. And you can also charge it at the same time with 3,000 watts from the wall using a special adapter, or 1,800 watts just as it is. So you can charge at over 4,000 watts with full solar and full wall charging. So let's go ahead and talk about price on this all-in-one power station. Now with all the features, it is pretty expensive. The MSRP for this is $3,800. Now I have seen it on sale for $3,500 before, but I will tell you Bluetti has provided a special discount code to my viewers, and it's active for 1 week after this video goes live, and it brings the price down to $3,400, which is the lowest price I've ever seen on this power station. Now this power station also comes with a 4-year hassle-free warranty. So when you spend that much money, it's nice that you can actually have a warranty for 4 years. And I'm guessing the hassle-free warranty means that Bluetti will replace the AC300 or replace one of the batteries if they have an issue, or refund your money. Now this is probably one of the biggest power stations and charges so fast that I'd actually call this one a solar generator. With 2,400 watts of solar capability, you could definitely run things and charge the power station as fast as a gas generator would, at least a small one. Now in this video, we're going to do extensive testing on the DC output, AC inverter, all the features of this power station. We're going to do capacity tests to see how it stands up to its advertising claims. And at the end of the video, I'll be throwing this through my new power station grading system, giving it a score of 1 to 10 based on its performance, price, features, and any issues that I find, so you guys can compare it directly to the other power stations I've already tested. Now, I hope you guys are excited to hear about this power station. I've been very impressed with all the features on this. Let's go ahead and get started testing the DC output. Now, I first want to jump into testing the DC output on this power station. Now, just be aware, this is the main control unit called the AC300, and there's a separate battery or multiple batteries that attach through these cables here, and that's called the B300, and that's on the ground. Now, you have to have the battery plugged in for this to function. Now, there are multiple USB ports available on this power station. You have a 100-watt USB-C output, you have 2 quick charge USB-A ports, and then you have 2 of the older style 5-volt 3-amp ports. Now here's a quick demo of how you could use the USB ports on this power station. You could take the 100-watt USB-C output and charge a laptop or a power station. You could power USB LED lights or USB fans. You could charge cell phones or even charge batteries if you have a USB battery charger. Now on the top of the AC300, there are 2 15-watt wireless charging pads, and each of the expansion batteries have 2 USB ports, a 100-watt USB-C output and a USB-A quick charge port. Now on this side of the power station, you have your DC outputs. This is a 12-volt dedicated 30-amp output, and this is a special 24-volt output. Now this looks like a regular cigarette plug, but it actually puts out 24 volts instead of 12 volts, and it has a warning right here. Let me go ahead and show you the benefits to using this port. Now if you have a smaller power station like this Bluetti EB70, now this can handle 28 volts input, and this jack over here actually puts out 26 volts. So you can see we're actually maxing out the charging on this power station. We're getting 200 watts input using this output connector, which is pretty awesome. So this output is a really fast way to charge your smaller power stations. But you have to be careful, not all 12-volt appliances are compatible with 24 volts output. So you have to look in the owner's manual and see if they can handle this high of a voltage. If not, it could fry the appliance. Now, 12-volt compressor fridges or portable fridges are also compatible with 24 volts, at least most of them are. So you could plug a 12-volt compressor fridge into this output as well. Okay, so I pulled out both my battery load testers, I connected them together in parallel, and they are hooked into the 24-volt output. Let's go ahead and start cranking these up to see how much power we can pull before it shuts off. Now this output is regulated at 25.5 volts, so make sure your device is compatible with this level of voltage before plugging it in. Okay, so I have each of these set to about 5 amps, so we're pulling over 250 watts out of that 24-volt output. I'm slowly going to turn this up until it shuts off, so let's go ahead and see what happens. So it looks like this output can handle up to 275 watts before it shuts off from being overloaded. Now let's move forward with testing the 12-volt 30 amp output. Now just be aware, this cable right here does not come with the power station. This is actually from my Energizer PPS 2000 power station. I have both of these connected in parallel to that cable. Let's see what this is regulated at and how much power we can pull. Now one thing I noticed on this output is it actually jumps around, so it's 13.6, 13.3, 13.2, and we have a very small load on here, so not quite as regulated as I've seen on Bluetti power stations before. Usually it's solid at 13.5, but this one's jumping around just a little bit. Okay guys, I can't do this very long. These battery load testers are rated at 150 watts and I'm pushing it past. 178 watts on this one, 15 amps, 170 watts on this one at 14 amps. Let's go ahead and take a look at the screen. Okay, so we're pulling 390 watts out of the DC output. That is an awesome amount of power. Now, if you absolutely need to run a 12-volt appliance using a 12-volt socket, don't worry, the B300 actually has a dedicated 12-volt socket on it. So you can actually take this battery by itself or hook it up to the power station. All you have to do is turn on the DC output by pushing this button, and then it activates this 12-volt socket. So let's go ahead and plug in my battery load tester and see how much power we can pull from this socket. Okay, so I have it cranked up to 10 amps. We're actually pulling 130 watts out of that 12-volt socket. Let's go ahead and try turning it up to see when it turns off. Okay, we got right around 145 watts before it shut off from being overloaded. Now, just in case any of you were wondering, this power station combo and battery weighs 127 pounds. So my lifetime table here that is plastic is really feeling the stress. So for the next test, we're gonna move this back to my workroom. Okay, so the last test that I wanna do on the DC output is a full discharge test. So I have this charged up to 100%, and then I have both my battery load testers connected up to the 30 amp output. We're gonna take it from 100% down to 0% and see how many watt hours you'd expect to get during one full discharge. Now remember, this is rated at 3072. Let's see what we get on the test. Okay, it's gonna be kind of hard to see with just the reflection here, but 10 amps on this one, 10 amps on this one. You can see it just started about 1 minute ago. So let's go ahead and let this run all the way down to 0% until it shuts off and see what we get.
A little longer than a few minutes later.
Okay, so the AC300 just hit 0% and shut off the DC output. Let's see how many watt hours we got on our battery load testers. Okay, so let's go ahead and total these up. We got 1197.1 watt hours here, 1196.33 watt hours here. Now the test ran for 9 hours and 34 minutes. And you can see we pulled around 97 amp hours on this one and 96 amp hours on this one. So if we add those up, it's 2393.43 watt hours total. Now, if we take those results and divide it by the total capacity of 3072, that gives us 77.9% of the advertised capacity. So taking this from 100% down to 0% using a 20 amp load, you're gonna get around 77.9% of the advertised capacity. Now, I would have liked to see a little bit higher efficiency on this DC output, but I was thinking about it. There are some trade-offs to having a 30 amp output. For example, you have much larger components inside this power station to handle the 30 amps, so you're gonna get a little bit more loss over time. Now, if this had a 10 amp output, you probably would have gotten a little bit better results, but you can't power as many things. So you have to think about it. Would you rather have the 30 amp output and have a little less efficiency, or a 10 amp output and not be able to power as many things? Now, I know some of you will probably be asking, well, Jason, why didn't you do a discharge test off the B300 as well? Because it actually has a 12 volt, 10 amp output that probably is a little bit more efficient because you're bypassing all the large electronics in the AC300. Well, guess what, guys? I actually did do a discharge test with the B300 12 volt output. Let's go ahead and take a look at that video. Now, one thing that's really cool about this B300 is that you can actually use it on its own as a standalone battery. Now, this is a huge battery. It weighs 80 pounds. It has 3,072 watt hours, and it has a few outputs. It has a 12 volt, 10 amp cigarette plug, a 100 watt USB-C output, and a 18 watt quick charge port, so you can charge cell phones, laptops, run 12 volt compressor fridges, a lot of things that you can run off this battery. It even charges on its own with 2 charging ports on the side that I'll talk about later in the video. But I want to see how much power is in this battery, or at least how much power you'd get as you take it from 100% down all the way until it shuts off using both these battery load testers. So I'm going to set each one to 5 amps and start the test. It's going to run for about 24 hours. So it's going to be a long one, but let's go ahead and discharge this battery and see how many watt hours we could get through that 12 volt socket. Okay, so I just started the test, a little bit less than 5 amps on each battery load tester. Now it's tracking the time and the total watt hours. So let's see what happens.
Many hours later.
Okay guys, the battery is completely discharged, everything turned off, and it ran for 20 hours. Let's go ahead and take a closer look to see how many watt hours we got. Okay, so let's go ahead and add this up. We got 1,275.85 watt hours here, 1,285.82 watt hours here, and that basically comes out to be 2,561 watt hours. Now, if we take the 2,561 divided by the total capacity of 3,072, that gives us 83%. Now remember, on the other test, we got basically 77% of the rated capacity, or 2,393 watt hours. So if you're looking to run a DC device over a long period of time, you're gonna get more power out of just using the B300 output instead of going through the actual AC300. So pretty interesting results. Okay, so let's go ahead and jump into testing the AC inverter on this power station. Now this is rated at 3,000 watts, and it does put out 120 volts, and it is a pure sine wave. So we'll go ahead and test that just to make sure. But you see we have 6 different 20 amp outlets, and then we have a 30 amp outlet. So a lot of potential with this power station. Now I just plugged in my voltmeter into one of the 20 amp outlets, and you see we're getting 120 volts AC. Now I just swapped my meter over to oscilloscope mode, and you can see we're getting a pure sine wave output, sitting right at 60 Hertz and 112 volts RMS. Now, if you're planning to use a power station like this for an emergency backup or even to run things off solar, you have to know if it puts out clean power. And by doing this testing, we just confirmed that all the AC power from this power station is very similar to the power that you get from your power company. So this will handle sensitive electronics like laptops and desktops. You can run all different types of power tools, appliances, or even full-size fridges off this power station. Now, I previously mentioned that this can handle 3,000 watts, and that is the continuous load for the inverter. However, it does quite a bit of surge wattage. For example, the inverter can surge from 3,100 to 3,750 watts for 2 minutes. It can handle 3,750 watts to 4,500 watts for 5 seconds, and 4,500 watts to 6,000 watts for half a second, or 500 milliseconds. Now in the next portion of the video, I want to test the AC inverter at max continuous load, so 3,000 watts. Let's go ahead and see if it can handle 3,000 watts for 15 minutes. Okay, so I got everything plugged in. It's going to take a second to get everything turned on, but let's go get the AC inverter turned on. Okay guys, we're pulling 2,930 watts. This is really close. So let's go ahead and hold this load for 15 minutes. Okay, so I just started the timer. We'll come back at 5 minutes to see how everything's going. Okay, we're hitting the 5 minute mark. Let me go ahead and bring this up, see if you can see this. Yep, 5 minutes. Now I have this set to oscilloscope mode. You can see we're getting just a little bit of noise on here. So you can see that. Just a little bit of peaks on the bottom and the top. Still pure sine wave output. Now looking closer, I actually adjusted the load. Now we're a little bit closer to 3,000 watts, so 2,985 watts. Let's go ahead for another 5 minutes and see if it can handle 10 minutes of the load. Okay, we're coming up on the 10 minute mark. Just throw you guys the timer here. Say 9 minutes, 35 seconds. Now we're still getting 119 volts, so very good on the voltage. Battery has dropped down to 76%. Let me show you closer on the screen. Okay, so 2,979 watts, 76% on the battery. Now, one thing to note, the fans on this are very large and they move slow, so it's actually very quiet, but a lot of airflow and quiet fans. Okay, never mind. The fans just kicked on full speed now. They're a little bit louder. I'd say they're probably the same loudness as the EcoFlow Delta Max fans. So anyway, once you're running a max load for about 15 minutes, you're gonna have the fans kick on pretty loud. Okay, so we just hit the 15-minute mark. I'm going to show you guys the timer. There we go, 15 minutes. Now we're still getting around 119 volts output. So here's a closer look at what the oscilloscope's showing. Just getting a few peaks on the bottom. I'm not sure what that means, but it still is putting out a pure sine wave, just it's not absolutely perfect. But this is a pretty large load at 3,000 watts. So this was able to run for 15 minutes at full load. In fact, it's still going. Overall, very impressive. It pulled 3,000 watts, didn't shut off, and everything is still running. Okay, so I just shut off the AC inverter. Now we were able to pull 3,000 watts for 15 minutes without any issues. The power station didn't overheat and didn't shut off from being overloaded, so I definitely call that a success. This thing can handle a ton of wattage. Now I've had a lot of requests to see if there's any noise on these larger power station inverters. So I have this orange guitar amp plugged into my wall outlet to see what it sounds like first here. And then we'll plug it into the AC300 inverter to see if we get a similar noise output. So this should tell us how noisy the inverter is and if it supports musical equipment or any equipment that is sensitive to interference. Let's go ahead and test this out. Okay, so the first test I'm going to do with this plugged into the wall. So let's go ahead and see what it sounds like when it's running off wall power. Okay, so here's a test with the inverter at 0 load. This is what it sounds like when the inverter's at a 1800 watt load. Okay, so what does this test tell us? Well, it tells us that the amp sounds the same when it's plugged into the AC outlet versus the AC inverter on this power station. So the inverter on this power station puts out clean power. We didn't hear any pops or snaps or any weird hums when the amp was running off the AC inverter. Now, a few weeks ago, I put out a video about how I'm using the AC300 to power 6 circuits in my home via a transfer switch. Now, I did this because I wanted to have a home backup battery in case the power goes out. But while I have this here and hooked up and solar coming in, I might as well run those 6 circuits during the day off the AC300. And then at night, to save battery power, I turn off 4 of those circuits and just run 2 of my full-size refrigerators. Now, usually when I come in the morning after powering both full-size refrigerators, the battery percentage is sitting around 25 to 18%. And if the sun is shining, I can easily swap it back over to the 6 circuits to run off the AC300 because it's charging really quick in the morning. Now, if it's a cloudy day, I can't really run all 6 circuits or the battery will run down to 0%. So that should give you a good idea of what to expect powering things off the AC300 for 24 hours. Now, in a power outage situation where I don't have decent solar power coming in or at night, what I'd plan to do is charge up this AC300 using my 2000 watt gas generator. Now, the benefit to charging this up with a gas generator means that I can store all the extra power in this battery and not run my gas generator all the time. It would run for about 2 hours to charge this up, and then I could save on gas in hopes that I'd have supplemental solar coming into this, and then alternating between the gas generator and solar, I could power the 6 circuits in my home via the AC300. Now, I will put out this warning, you always have to be aware of what you're trying to plug into those wall outlets because this won't support everything you plug into the wall and run it at the same time. This has a limit of 3,000 watts. For example, you could run 2 full-size refrigerators, a microwave, and some lights, but you probably couldn't add a large vacuum on top of that or it would overload the AC inverter. So you always want to separate your large loads at different times so that you don't overload the 3,000 watt continuous limit on this power station. Now, over the last month or so of me testing this via the transfer switch, I've never actually overloaded the AC inverter because I've been very careful to run large loads at different times of the day. Anything that I've plugged in the AC inverter has worked without any issues and I've been very happy with it. Okay, so the last test that I want to do on the AC300 inverter is a complete discharge test. Now I have this charged up to 100%. We're going to take it all the way down to 0% with a 20% load and track all that through that kilowatt meter. Now this will tell us how many watt hours we should expect as this has one full discharge, and I'm hoping for at least 85%. So let's go ahead and start the test and see how many watt hours we can get. Okay guys, the power station just shut off from hitting 0%. You can see the battery is drained on the error message here. So let's go ahead and plug in some solar, charge it up so we can turn on the AC inverter and see the results we got. Okay, so I've been charging it up with solar here. We're getting around 1,000 watts, have quite a bit of high clouds today. But the AC inverter is now enabled so we can see what we got on the watt meter. So we actually pulled 2,620 watt hours. Now with this being advertised at 3,072, if we divide it by that, it comes out to be 85.2% of the advertised capacity. Now thinking about the actual size of this power station being able to handle 3,000 watts, you got to know that there is some loss going through such a large inverter like this. So pretty impressive that we were able to get the 85%. Okay, so now that we've tested the DC output and the AC output on this power station, now's a good time to talk about the parasitic drain. And this is a new test that I've been adding on all my larger power stations. And the parasitic drain basically means how much power is lost as it's sitting idle, turned on, but no output is being used. So how much does the inside inverter just waste over time, or how much does the DC output waste over time without a load? So I've done 4 different tests on this. Let's go ahead and dive right into it. So with the AC300, no outputs enabled, so just the screen on, it lost 1% over 2 hours, so 0.5% per hour. Now with the AC300 DC output turned on, we basically saw a 1% loss per hour. So if it was at 100% and you left the DC output enabled with no load, you would see it drop 1% per hour. Now with the AC300 AC output turned on only, and you had it charged up to 100%, you'd see 2% per hour. Now this is the biggest way that this loses power is, AC output. This AC inverter is a large inverter and it does have a lot of background drain. So 2% hour is basically what I saw on this. So if it was charged to 100% and you came back 5 hours later with nothing running on it, it'd be down to 90%. Now the best way that I've found to fight this parasitic drain is just to have solar panels plugged into it all the time. Now during the day, I can keep this thing at 100%. Even with those 6 circuits running on this, I've only seen this drop down to 98%. And that's because I have, around 1,600 watts of solar coming into this. It runs all my loads and it runs, keeps it charged up. Now with everything enabled, so DC output, AC output, Wi-Fi, Bluetooth, and the screen, I saw 3 to 4% per hour. So just make sure that you shut off the outputs that you're not using, and make sure the screen timeout is enabled so it turns off the screen when not in use, and you'll limit your parasitic drain as much as possible. Now just remember, when this is completely turned off and the battery's turned off, you don't lose much power at all. It basically stays charged to 99% for weeks on end. You want to turn it on every couple months to charge it up just to top it off, but you're not going to be losing tons and tons of power as it's like sitting in a closet somewhere. Now, I definitely don't recommend leaving this in a closet. Use this thing every day. You're going to get 10 years of use out of this thing, and you want to start getting a return on your investment. So just a little bit of information about the parasitic drain. Hopefully you guys find that helpful. And this is pretty normal parasitic drain compared to other power stations that I've tested. 1 to 2% per hour or 0.5% per hour is pretty normal. Okay guys, it's time to talk about charging up the AC300. Now this is one of the main benefits of this power station is how fast it can charge. Off solar panels alone, it can charge at 2,400 watts, which is one of the fastest charging power stations I've ever tested. It has 2 MPPT solar charge controllers that can handle 1,200 watts each. It can also charge at 3,000 watts from the wall or a generator, and it can dual charge with both those inputs at 5,400 watts. Now it comes with 3 different charging cables. Let's go ahead and take a look at those. Now this is the AC wall charging cable that comes with the power station. This supports 15 amps or 1,800 watts of wall charging. So you can plug this into a generator or your wall outlet to charge up the AC300. Now the default setting for this power station charging off the wall is 15 amps, but you can actually lower this if you want to have it charge slower. So you can come in here, click basic mode, and then you can set it to 5 amps or even 1 amp, click OK. And you can see now it charges at 1 amp, which would be 1 times 120 volts. So this would be charging at 120 watts if you wanted to, but I like doing somewhere around 5 amps. So we'll do it at 5 amps there. Now the next cable that comes with the AC300 is your solar charging cable. Now what's special about this is there are actually 4 individual conductors in here, and that explains why there are 4 MC4 connections on the end. You have 2 connections for one solar array, positive and negative, and then you have 2 connections for a second solar array, positive and negative. Now all you have to do is connect up panels that are set up to be within 12 to 150 volts, and you have an amperage limit of 12 amps. So lots of potential for both of these connections. Now when you're using solar panels, you do want to come into the settings and make sure your DC input sources are both set to PV instead of other. Now one other solar setting that I had to disable because both of my arrays are different voltages, I had to turn off this PV parallel enable. So once that's set to off, it was able to accept both different types of solar arrays. Now if your solar arrays matched in voltage, you'd probably want to have this enabled. Now the last charging cable that comes with the AC300 is this DC to DC charging cable. Now the MC4 connections connect up to your solar panel input, and this plugs into a 12 volt socket in a vehicle or off another power station or battery source. Now whenever you decide to use the DC to DC charging off a vehicle battery, you're going to want to come in here to the source that it's connected to and change it to others. Now what this does is it drops the amperage limit from 12 amps down to 8 amps so you don't blow the fuse in your vehicle. Now what's cool about this is you can have a solar panel plugged into one, and then you can have your car plugged into the other, so you can get dual charging off solar panels and your car alternator. Now just note that this DC to DC charging cable off a vehicle battery or another battery is the slowest way to charge up this power station. You're going to be charging at around 100 watts when you use this cable. Well, now that I've showed you each of the adapters that come with the power station, let's go ahead and go outside, take a look at my solar panel arrays, and then we'll connect them up. And then after that, we'll do some charging off the wall adapter, and then we'll try some dual charging. Now I have 2 different solar arrays that I always have plugged into this power station. This first one uses 180 watt Booz RV solar panels, 4 of them connected together in series. And then I have another set over there. Those are 325 watt solar panels, and they put around 36 volts. And I have those connected in series. So both of these arrays plug into the AC300. Now I am planning to mount the solar panels up here on my shed roof, and I'm almost done with that, so I'll have a video on that soon. That's where those panels are going to go. Now for solar conditions today, it's a mix of sun and clouds. It's around 65 degrees, so we'll see what we get. We're going to be fighting a lot of clouds today. Okay guys, I'm back inside. I have my solar panels connected up to the AC300. Let's see how fast we're charging. Okay, so we're getting right around 1300 watts charging input using both solar panel arrays that I have set up. Now you can see the first array is sitting at 102 volts at 763 watts, and we got 67 volts and 533 watts on the second array. So pretty awesome. You can use 2 different arrays with different voltages and get all this power input on the power station. Now with the current weather conditions today and the way that my panels are oriented, I'm not seeing the maximum input that I've seen before. I'll throw a screenshot up, but I have seen over 1500 watts charging. That was pretty awesome. Now remember, this can handle up to 2400 watts, 1200 watts on each MPPT solar charge controller. Now this is one of the first power stations that I would actually call a solar generator, because at 2400 watts input, it actually puts out more power than a regular small gas generator would. So you could definitely call this one a solar generator. Okay, so we're swapping gears. We're going to go from solar. Now we're going to AC wall charging. I have the cable plugged in over here to the wall and on the power station. Let's see what we're charging at. Okay, so taking a closer look at the screen, you can see we're getting grid power, but it's not showing any wattage. And then I remembered that I had in the settings, I have this set to a UPS mode of PV priority, which means if the battery is over 30%, it's going to prioritize solar panel input. So let's go ahead and set this to standard UPS mode, and then we should be good. This is going to start charging now. Okay, so now we're charging off the grid. Now remember, we have the setting in here where it is set to 5 amps. So let's go ahead and set this to 15 amps. There we go, guys. Now it's pulling in power from the wall. Now, let's go ahead and plug in solar panels at the same time to see how much max power we can get off dual charging. Okay, guys, check this out. 1300 watts coming in on solar panels, 1750 watts coming in from the grid, for a total of 3,000 watts charging on this power station. That is insane. Now, I hate paying for power from the wall when I have good, decent solar coming in. So what I want to do is go back into the settings, and I'm going to change the working mode UPS back to PV priority. And let me explain how this works. Now, what PV priority does is when it gets below 30%, that's when it'll kick in grid charging. But it's going to prioritize solar panels coming in until that drops below 30%. So if you want to mostly get power from solar to power your devices, then you set it to PV priority. And that's what I always have this set to. Now, one thing that I always like to make sure a power station can do is handle pass-through charging without any issues. Now, just remember, I had the AC300 hooked up to a transfer switch for about 3 weeks testing it out, and I never had any issues charging and discharging at the same time, but I just wanted to demonstrate that it's just fine in this video as well. So right now I have this large heater connected up to the AC inverter. I have this small power station charging off the 24 volt output, and I'm charging at 1300 watts with solar panels, and there's no issues whatsoever. Now, since you can use the B300 as a standalone battery without the AC300 attached, I want to show you guys how you can charge up this battery. So on the side of each B300, you have 4 different connections or inputs. Over here is where you connect it up to the AC300, and they have these covers. And over here, you have your DC inputs for charging the B300. Let's go ahead and zoom in on these. Now let's go ahead and talk about the top charging port first. So this is what you call an XT90 connection, and it handles 12 to 60 volts DC all the way up to 10 amps. So you can basically plug in a smaller array of solar panels that don't go over 60 volts. You could also plug in a car 12 volt or 24 volt output to charge this power station. And there are cables that you can buy from Bluetti that come with this. For example, this one came with my AC200P. It's XT90 on this end, and then cigarette plugs. So you can plug it into your car to charge it up. Or you can have an XT90 to MC4 connection. So there's plenty of adapters and cables that will plug in here so you can charge it up. Now, the second way to charge up this battery is using the input jack here at the bottom. This is a 7909 or 8mm connection, and it's actually designed to be used with Bluetti's higher voltage charger, which is their 58.8 volt 8 amp charger that comes with the Bluetti AC200P. And here is an example of that 8mm adapter, and you can plug that in here and charge this battery up around 500 watts using AC power. Now, if you're looking to hardwire this into a system to charge it up, you can actually go out and buy these XT90 pigtails. I'll include the link where I purchased these down in the video description, but they're fairly inexpensive, and you can set up your own wiring system using something like this, so you can plug it right in without having to purchase Bluetti's adapters. Okay, so that's basically the charging demo that I wanted to show you guys about the AC300 and the B300. Now, it didn't show all the charging options, and there are more things that you can go out and buy to make this charge even faster. But for the average person, I'm hoping that this part of the video covered everything that you'd need to know. Okay, let's go ahead and take a second to talk about the app. Now, it is available on Android and Apple devices. And once you connect to the AC300, you have this screen here. So you see we get 1100 watts through solar input right now. We're not charging on the grid. Battery sitting at 15%, and you can see your AC and DC outputs here. And you can toggle those on and off by pushing this button. Now, at the bottom, it kind of gives you this cool fact of how many kilowatt hours you've generated through solar panels, and I'm sitting at 36 kilowatt hours. Now, you come up to your settings here. You can change your UPS mode and when it turns on, like wall charging for PV priority. You can set the screen timeout so when it turns off, and you can see your device information. And what's really cool is you have a firmware upgrade. So if they find any issues with this power station, they can fix out any bugs through pushing a firmware update through the app. Now, I've had a lot of people talk about, well, what if the screen dies on the power station? This is a great opportunity to be able to control the power station if the screen goes down. You just want to make sure that you always have the Bluetooth enabled so that if the screen does break, you can connect with your app. Now let's go ahead and talk about the display on the AC300. It's very familiar, so if you're familiar with a Bluetti display, this is not going to be new to you at all. Now on the home screen, you have basically 4 breakdowns of what's happening. You have your charging input up here, which is currently set to solar panels. And I like how it breaks it down to individual charge controllers. Then you have your grid input here if you're charging off a wall or a generator. You can also see the DC load output here and the AC inverter output here. And you can toggle both those on by pushing these buttons. Now in the middle, you have a state of charge percentage, which you can then click on and you can see each individual battery pack that's attached, and you can see what percent it's sitting at. Now I only have one battery attached, so you can see just that one there. Now let's go ahead and talk about the settings on this power station. There are so many settings, so I'm just gonna fly through this. So AC output voltage, you can change between 100 and 120 volts. Also the frequency between 50 and 60. And then this is where you change your input source from solar panels to other. And from my understanding, this basically just changes the amperage input. Now you can turn on and off eco mode. This is disabled by default. This will basically just turn off the AC inverter after 4 hours or so if there's no load. I leave eco mode off because I use this all the time and I always want the AC inverter on. Right here, the machine type single phase, that means it's putting out 120 volts. Now you can purchase a second AC300 and use a special adapter to put them together, and you can set it to dual phase where you can put out 240 volts. Working mode is really cool. There's lots of UPS options here. Now the standard UPS means it'll charge off the wall, and when the power goes out, it flips over to the batteries. Time control, you can actually set it up so it only charges during certain times of the day. So you can charge during cheaper electricity hours, usually at night. PV priority means that you can set a certain percentage in the power station where it will charge from solar panels, say 30% and above, and then it'll charge from the wall when it's less than that. So I always have this set to PV priority. It's really nice. And then customize UPS, you can change basically any setting you want in customized. Now silent mode, you can turn that on and off. Basically turns off everything that would come from this screen. So you can just turn that, make it quiet. Max grid input, I have it set to 15 amps. Remember, this can go to 30 amps, but you have to go into this advanced mode and purchase an additional charging adapter, and you need a password to get in there. But you can go from 1 to 15 amps in basic mode without any problems. Now PV parallel enable, this basically means that if your solar panel arrays match, you can come in here and turn this on. But because my solar panel arrays voltages are different and they're different panels, I have this set to off. Now what's really nice is there's Bluetooth connectivity and Wi-Fi connectivity, so you can choose to use Bluetooth if you want to use privacy and not have this on your home Wi-Fi. Or if you're on vacation, you can connect this to your home Wi-Fi and access it from outside the home using the app. Now the app uses both of these, so it's nice to have that, and you can turn them both off. And you can see Bluetooth state is connected because I am connected with my Bluetooth app. Now you can turn off the buzzer, you can turn off the touch sound, and you can adjust the backlight. And you can set the time and date, which I haven't really set, so these are kind of off. And then the sleep time is for the screen. So you can actually set this screen to turn off after 5 minutes or 1 minute or whatever. So it's nice that you can save power by turning the screen off. And then you can factory reset the settings by this last option. And what's great is you can go right to the home page by pushing that home screen button. Okay, so we're at the end of the video where I want to put this through my power station grading system based on its price, performance, features, and any issues that we found. So let's go ahead and jump in to the grading system. Now, number one, does this power station charge up in under 4 hours to 100%? Yes, with full charging capability, this can charge up in under 2 hours. Number two, does this support pass-through charging, meaning you can use it and charge it at the same time? Yes, this has built-in UPS modes and functionalities, and it definitely supports pass-through charging. Number three, does this have a pure sine wave inverter? Yes, we saw a pure sine wave, 120 volts output, 60 hertz, no issues with the inverter. Number four, does this have a regulated DC output? Yes, the DC output is regulated at 13.5 volts. Number five, does this power station have an informational display, or is it missing any information? No, this gives you everything you want to know about the power station on the screen. Number six, are there any auto shut-off settings on this power station that would just turn it off randomly after a given amount of time? During the 3 weeks of me using this power station on my backup transfer switch, I did not have anything shut off. So there are no eco mode settings on this. You can enable one in the menu, but it's disabled by default. Number seven, USB support on this power station. Does it have USB-C output? Yes, it does. Does it output 100 watts? Yes, it does. And does it charge in on the power station at 100 watts? No, it does not. So this gets 0.66 points out of 1 point available. Number eight, super important, does this one reach at least 85% of its advertised capacity? Now on multiple discharge tests, the highest one we got was out of the AC inverter, and we got 85.2%. So yes, you did get 85% on this power station. Number 9, does this power station charge up to 100% in 5 hours just using solar panels? Now, most people will have around 5 to 7 good hours of solar per day, so it's really important to get this thing to 100% within 5 hours, and yes, it does. This thing charges so quick with 2,400 watts of max solar input. And number 10, probably the most important, is the price per watt hour. Now, is this priced at a decent price or is it super expensive? Well, the price per watt hour on this one on the discount comes in at $1.10 per watt hour, and on the MSRP is $1.23 per watt hour. Now, I usually like to see power stations around 80 cents per watt hour, but I understand with a power station this big and all the features, you're going to be paying a little bit more money with it, and especially not having any issues, you know, having the app and the ability to upgrade firmware, it's going to be more expensive. So this one does not meet that criteria of being 80 cents a watt hour or cheaper, so I cannot give it a point there. So this comes out with a total score of 8.66 points out of 10 points. So an excellent score for the AC300. And remember to check out my power station grading system. I'll have that down in the video description so you can see how other power stations I've tested stack up against this one. Okay, so let's go ahead and wrap up the review video for the AC300. This has been a huge video, lots of stuff to test, so thanks for sticking around to the end of the video. Now, the whole purpose of the video is to give you guys an unbiased, honest opinion about how the power station performs, and that's why I do all these tests, so you guys know what to expect if you purchase an AC300. Now, there are so many different options you can go with. You can go with a full DIY setup, you can go with a smaller power station, or even a competitor to the AC300. Now, if you're looking for a small option, Bluetti offers the AC200P and the AC200 Max, both really good power stations for the price, and they come in a lot cheaper than the AC300. Now, if you're looking for a competitor, you can go with the EcoFlow Delta Pro. It is priced similarly, but I don't think it charges quite as fast via solar panels. And I can't do a side-by-side comparison because I don't have both power stations, but maybe in the future, if the channel continues to grow, I can have that option to do a side-by-side comparison between both power stations. If you have an AC300, throw a comment down below what you think about it. How has it been working for you? Have you had any issues? What has been your experience? Anyway, guys, if you liked the video, please give me a thumbs up. The thumbs up and comments always help my videos get more traction. And if you aren't subscribed to the channel, I invite you to subscribe, because if you like solar panels and power stations, batteries, you're gonna like future videos coming out on this channel. Thank you for watching, guys. Hopefully we'll see you guys in the next video. You know, all the details of everything.